Unit 1, Day 3, Notes on Combining Like Terms and Perimeter. All right, so one important word that's in the title here that you may not have even totally picked up is like terms. Combining like terms. Okay, like terms are expressions. Let me read my definition I have here. They are terms with the same variables raised to the same exponent. Okay, so expressions that have the same variables and same exponents. So right here, 3x and 4x. Okay, those have the same variable, x and x, same exponent. So you just add the coefficients there. 3 plus 4 is 7. Example 2, 5x squared plus 2x squared. Okay, same variable, same exponent. So we just take 5 plus 2 and get 7x squared. 5 plus 2 is 7, so 7x squared. We don't do anything with the exponents right now. Okay, don't even touch the exponents. Keep them the same, keep the same variable. Example 3, 7x cubed plus 4x squared minus 2x cubed. Two of these have the same variable and same exponent, the 7 and the 2. That's why I underline them. 7 minus 2 is 5, so 5x cubed, plus the 4x squared. Just kind of keep that over there. All right, a little more complicated. Example 4, 4x cubed. And I'm actually going to underline the ones of the same variable, same exponent. 4x cubed minus 3x cubed. Okay, I'm trying to draw something that's a little different than just underlining. Okay, so 4 minus 3 is 1, so 1x cubed. And then here we have plus 3x squared minus 2x squared. So 3, positive 3 minus 2 is 1, so 1x squared. Okay, so that's how that works. Same thing here, we get 4x squared plus 6x squared. Okay, so that is 4 plus 6, so 10x squared right here. And minus 2x cubed minus 2x cubed. We like to have the highest exponent first. Okay, so that's how it's going to work. So let's dive into some of these problems to work on. Okay, so on number 1, simplify by collecting like terms. So first off, same variable, same exponent. That would be the 5a minus 7b. 3a plus 5b minus 7b. Okay, so the two b terms go together. So we're going to keep 3a and bring that down. But we're going to have 5 minus 7. Okay, 5 minus 7 will always have a b. 5 minus 7 is negative 2, so we're going to have 3a minus 2b. And there's our answer. Okay. Number 2, we have 8s minus parentheses 3s plus 4k. The 4k is all by itself, so I'm just going to go and bring down plus 4k. But we have 8s minus 3s. 8 minus 3 is 5, so 5s plus 4k. Same thing on number 3. We have 10x minus 5x. So we'll put those two together. We have 5x plus 6y. So plus 6y. Again, they have to have the same variable, same exponent. Okay, number 4, 16a plus 9 minus 7a. So we have 16a minus 7a. So that would be 16 minus 7 is 9. So we have 9a plus 9. Okay, number 5, we have 2.7a. We have another a over here. Those together, 2.7 minus 1.3 because of that minus sign there. 2.7 minus 1.3, so that's 1.4a plus 2b. Okay, number 6. Just go move me up in the corner. All right, number 6, we have 2x, and we have 7x over here. We have a minus 6y and a plus 2y. So 2 plus 7 will give us a 9x. And with the y's, we get negative 6 plus 2. So a negative 6 and a positive 2 should give us a negative 4. So minus 4y. Okay, next we have 7. Okay, here's where the exponent's going to be important. So we have 6s squared minus 3s squared minus 6s squared. So those three are going to go together. We know we're going to an s squared, but we need 6 minus 3 minus 6. So that's 3, so negative 3. So negative 3 s squared plus, it's all by itself, plus 4s. Okay. Number 8, same variables, same exponents. We have a 2bc. We have a 3bc. So we're going to have 2 plus 3 is 5, 5bc plus 4a plus 9a, so that should be a plus 13a. Okay, number 9, we have 3x minus 7y plus 5x minus 1y. Okay, so that should be an 8x and minus 8y. Negative 7 minus 1, negative 8. Okay, next we have numbers 10 and 11. I don't know why that's spaced out so strange, but it is. So let's see, same variable, same exponents. C squared d, c squared d with a minus 2 there. We have a minus 5, minus 7. They have the same because there aren't any. Okay, and then we have one other thing here. I'm going to try to make a different shape here. I'm going to just actually circle that one. That's all by itself. So we're going to have 6 minus 2, so 4 c squared d. I'm going to go and bring this down to minus 8d. Okay, and then negative 5, or minus 5 minus 7 should be minus 12. Okay. Now, a good thing to ask yourself here is, can we put anything else together here? Do we have any other variable, same exponents? We have c squared d, we have d. These two can't go together. They cannot go together because this one has c squared in it, this one doesn't. They have the same variables. All right, number 11. We're actually going to do this a lot later in the year, lots of times. So we'll have x squared. Let's go ahead and box that in. Minus 7x plus 4 plus x squared plus 4x, that's in a box, plus 6. All right, so x squared plus x squared, that's a 1x squared, so a total of 2. Let's see, those two together should give us a negative 3x. And those two, 4 plus 6, should give us a plus 10. So that answer is 2x squared minus 3x plus 10. Number 12, 3x squared plus a 5x plus 1x squared, 4x, that is not an x. 3x squared and x squared go together, plus 5 plus 6 go together, and we have plus 4x. So we should get 4x squared. 4x squared plus 4x. And then combining those to the 5 and the 6 plus 11. Okay. Now last on this page, number 13, we have a 5a. We have 1a over here, so that should be a total of 6a. We have minus 4b, minus 3b, so that should be minus 7b. And then we have box that in, plus 2c minus 6c. 2 minus 6 is negative 4, so minus 4c. Okay, now we get starting on number 14, we start looking at perimeter. Okay, perimeter, we're really going to have to combine like terms, but to find perimeter, you add up all the sides. Add them all up. So on number 14, we have a rectangle with 3k plus 4 and 2k minus 1 as the sides. So we want to find the perimeter, so I'm going to have to add these up. So I'm going to bring 2k minus 1, and 3k plus 4. So when we add these up, we get 3k, 2k, 3k, 2k. So that would be 2, 5, 7, 10k. And then adding these up, we get 4, that's 3, 7, minus 1 is 6, so 10k plus 6. Okay, we'll get the same thing for this next one. We have x squared plus 8x plus 15, x squared minus 3x plus 2, etc. Okay, so let's go ahead and find these. We have all the sides already, so we don't have to write anything in. Look over here. So x squared plus x squared, that's 2x squared, plus 2, that's 4x squared. Next we have 8x minus 3x plus 1x. So 8 minus 3 is 5, plus 1 is 6, so plus 6x. Now we have 15 plus 2, that's 17, should be 14. And there are all the sides. Right, number 16, we're told to write an expression that represents the perimeter of the square. What do the tick marks on the square mean? Each side is a tick mark, and it means that all sides are the same. Or all sides are equal. All sides are equal, so that means we can go ahead and just label these. 4p minus 3, 4p minus 3, and 4p minus 3. So grand total, we have 4, 4, 4, and 4. That is 16p. Minus 3, minus 3, minus 3, and minus 3 should give us a minus 12. So 16p minus 12. Okay. Number 17, write an expression that represents the perimeter of the regular hexagon. What does regular mean? It actually means exactly what the tick marks mean. It means that all sides are equal. All sides are equal. So we have 2c plus 1, 2c plus 1, 2c plus 1, all the way around. We have 6 of them. So if we do label these, 2c plus 1, 2c plus 1, 2c plus 1, okay, we're going to end up with 6 of them. Okay, we're going to have 6 of each of these. So we're going to have 6, so 1, 1, 1, 1, 1, so plus 6. 2, 4, 6, 8, 10, 12. So 12c, 12c's, and then plus 6. Right, number 18, write an expression that represents the perimeter of the irregular shape. What does irregular mean? Well, it means the exact opposite. The opposite of. Okay, so it means all sides are not equal. All sides are not equal. Okay. Just means we have to label all of them, okay, which in this case they're all labeled. We have B, 1, 2, 3, 4, 5. We have 5 B's, 3 minus 1 is 2, plus 1 is 3. So 5B plus 3. And then the last question we have is, if B equals 6, then what's the perimeter? That means instead of a B right there, we put in a 6. So 5 times 6. Times 6 plus 3. Well, 5 times 6 is 30. So this should be 33. Then the perimeter is 33. That brings us to the end of combining like terms. I want to remind you of that definition. You can only combine like terms if you have the same variables with the same exponents. And that's the end of our notes.